Good afternoon, everyone. Here is a review video for Math 006 7.3 and 7.4. Very similar to the previous video, I'm going to do all my 7.3 stuff in this blue, and then when I get to 7.4, I will, where's my choices at? I'm going to do it in that orange color here. So let's start with 7.3. 7.3 was all about adding and subtracting rational expressions that have a common denominator. We'll notice here that we're adding these two expressions. They do have a common denominator, so the only thing we have to do here first is going to be add the numerators. So first step is going to be add the numerators. I'm going to abbreviate this, add the numerators. So here we have x minus 5 plus 2, and then we're going to leave the denominator alone for just this step. And then we want to simplify that numerator. So here we have a minus 5 and a plus 2, which would simplify to x minus 3. Now what we can do with this denominator is factor it. So we would have x minus 3 and x minus 1 is how that would factor. Now we notice that the numerator and denominator both have a factor of x minus 3. Now, when we go to simplify this completely to write our answer, we'll notice that we have this x minus 1 in the denominator, but we have nothing left in the numerator, which means we're left with a 1. So that would be our final answer for that one. So we added the numerator, and then we want to simplify the numerator, and then we want to factor the denominator. And then we want to cancel out those factors of 1. Factor of 1. That's what we want to look at in order to do this. So let's look at another example. So here we're going to subtract and, if possible, simplify. We're going to follow those same steps that we just did right here, but instead of adding, we're going to be subtracting. We just want to be careful that when we subtract this numerator, keep in mind, all of those are going to be in a set of parentheses because it's an expression all on its own. So first thing we're going to do is we need to, oops, why is this not clicking? There we go. We need to, there we go, subtract our numerators. So we're going to have 20x squared plus 5x plus 1, and we're subtracting this whole thing of 8x squared minus 12x minus 5. And then this is going over top of our denominator. So 6x squared plus x minus 2. Now what we have to do is distribute this negative in the numerator here. So when we distribute that negative, it's going to change the signs of everything there. So this will be plus a negative 8x plus 12x plus, and that's a 5 there. So now I'm going to write it all together. So we have 20x squared. That's going to be minus, and I'm going to rewrite it in descending order at the same time, minus the 8x squared plus 5x plus 12x plus 1, and then plus 5. While I'm at it, I'm also going to factor that denominator here. We know that we need two sets of parentheses here. We know this will factor into 3x plus 2 and 2x minus 1, because I'd give us 6x squared plus a 4x minus a 3x minus 2, so that would give us that. Now what we have to do is simplify the numerator. So we'd get 12x squared, because we have to do 20 minus 8, and then we'd have plus 17x plus 6, and then bring down the denominator, 3x plus 2, 2x minus 1. Now we have to factor this numerator. I'm going to come up here. Again, keep in mind that if you have to factor something that looks a little bit more complicated, use these two factors here as a guide. Chances are this numerator will factor to have at least one of those factors within it. So go ahead, and what I want you to do is pause the video and see if you can factor that numerator, and then complete the rest of the problem. And then you can go back, hit play, and check your work. You will notice that I factored the numerator into 3x plus 2 and 4x plus 3. And then you can see I have in yellow here that the 3x plus 2 cancel out, and we're left with a final answer of 4x plus 3 divided by 2x minus 1. Okay, the next thing we're going to be looking at is finding the least common denominator and then an equivalent expression that has that given least common denominator. Okay, so when we look at this first expression, we see that this denominator is made up of two factors, a factor of x and a factor of x plus 3. Whereas the second expression, the denominator also has two factors, x plus 3, sorry about that, and let's see, a factor of x plus 3 and another factor of x plus 5. So we have to create the least common denominator here. So the least common denominator has to be made up of all the factors present. So again, I'm going to start by writing the first two factors that we see in the first expression. So x and x plus 3. Now, when we go to the second expression, we see that it has an x plus 3, but it also needs an x plus 5. So we're going to add that to our list of factors. So you can see our least common denominator will be made up of three factors, an x plus 3, and an x plus 5. So now what we have to do is rewrite these rational expressions to have that denominator. So we're going to start with the 2 over x and then the x plus 3. We'll see that this expression is missing the factor of x plus 5. So we have to multiply by a factor of 1 of x plus 5 divided by x plus 5. Now the second expression, we have 10 divided by x plus 3 and x plus 5. This one is missing the factor of the x, so we need to multiply by a factor of 1 of x divided by x. Now we have to go and multiply everything together here. So in the first fraction, we have the expression 2 times x plus 5, and we are dividing that by x, sorry about that. We're dividing that by x times x plus 3 times x plus 5. And then the second one, we'd have 10 times x, which is 10x. And we're dividing that by x, x plus 3, x plus 5. We're going to leave our answers just like this. If we were to be adding them, we'd have to do a little bit more with this first one. But for now, we rewrote each expression to have the same least common denominator. Now we're moving on to review of 7.4. Now we have to add or subtract our rational expressions that do not have a common denominator. First thing we have to do is factor the denominator. So I'm going to make a list here. So first thing we need to do is factor the denominator. The reason we have to do this is so we can identify the least common denominator. That's going to be the next step, identify least common denominator. Once we find the least common denominator, we can do what we did in this step, where we can write two equivalent expressions. So first thing we want to do is factor the denominators. So 2a minus 4, we see that these both have a factor of 2 that we can factor out. So this would be 2 and then times the quantity a minus 2. If we were to distribute that 2, we'd get the same thing. And then a squared minus 4, this would factor to a plus 2 times a minus 2. So now the least common denominator would be, we have a factor of 2, and then an a minus 2, those are going to be these two factors. Here we have the a minus 2, but we also need an, we also need an a plus 2. So what we want to do is create our rational expressions now. So in the first one, we have a over, and I'm going to write the factored form, a minus 2, and then we have to multiply it by which factor we're missing, which would be the a plus 2. So we're going to multiply both of these by a factor of 1, a plus 2 over a plus 2. And then we have to add that to, we have this negative 4 over, and again, I'm writing the factored form, a plus 2, a minus 2. And this expression is missing the factor of 2, so we do 2 over 2. The next step is we have to multiply our fractions together. In this first one, we have an a times a plus 2. We have to distribute that. So we take a times a is going to be a squared. A times 2 is plus 2a. Again, this is going to be over the 2a minus 2, a plus 2. Now with the second fraction, we have negative 4 times 2, which would be negative 8, over, and then our denominator of 2 times a plus 2 and a minus 2. Then what we have to do is add all of our numerators. You see we have an a squared plus 2a plus a negative 8. None of those are like terms, so we can just write them all together. A squared plus 2a minus 8, and then over the denominator of 2 times a minus 2, a plus 2. The last thing we have to do here, let's see, I'm going to come over here in this little spot because I'm running out of room, is going to be factor that numerator. So the numerator here we would have is a plus 4 times a minus 2. That would give us a negative 8, and then a positive 2 is our middle term, over our denominator of 2 times a minus 2 times a plus 2. Then we'll notice that we have an a minus 2 in the numerator and the denominator, so those will cancel, and we're left with a plus 4 divided by 2 times a plus 2. And we are going to leave our answer in that form. The next example we're looking at is a subtraction problem. Again, the first thing we want to do is factor the denominators. So the first one, this is going to factor into n minus 5 and n plus 3. The second fraction will factor to n minus 5 and n minus 1. So now we can identify our least common denominator. Again, I'm going to write both factors from my first fraction and then see what else I need in the second. N minus 5, we have one of those, but in n minus 1, we do not have, so we have to add that. So we have 3 factors that will make up our least common denominator. So now we have to rewrite these fractions so they have the same denominator. So we have 2n over n minus 5, n plus 3, and this one is missing the factor of n minus 1. So we have to multiply the numerator and the denominator by n minus 1. The second fraction, we have 5 over n minus 5 and n minus 1. And we have to multiply that one by the missing factor, which would be the n plus 3. Now what we have to do is multiply our numerators. You will also notice that each of these numerators only have one single term. If there was 2 terms, say 2n, and there was something else right here, you'd have to make sure you would distribute or FOIL appropriately. But here we only have one term, so you just have to distribute the 2n times the n, the 2n times the negative 1. So we have 2n squared minus 2n divided by, and now we have all 3 factors. Then we're going to be subtracting, and again, we have to distribute this 5n plus 15 over, and now we have all 3 factors here as well. Don't forget, now we have to distribute this negative to both of these terms here before we can start combining things. I'm going to do that all in one step so I don't run out of room. So we have 2n squared minus 2n, and we're going to subtract 5n and then minus 15. Again, I'm getting 2 subtractions here because we distributed in the previous step. And then I'm writing all 3 factors again, n minus 5, n plus 3, and n minus 1. The next thing we have to do is going to be combine like terms in our numerator. So we'd have 2n squared minus 7n minus 15, and we're dividing that by our denominator of n minus 5, n plus 3, and n minus 1. The next thing we have to do is factor this numerator, which would factor into 2n plus 3 and n minus 5. And then again, we have all this denominator of n minus 5, n plus 3, and n minus 1. Then we notice that the numerator and denominator both have an n minus 5, which cancels, and we're left with a final answer of 2n plus 3 divided by n plus 3 and n minus 1. Okay, last one I want you to try one on your own. So what I'm going to recommend it for you to do is pause the video and try to work through this problem. 3 divided by x minus 1 minus 3 divided by x squared minus x plus 5 divided by x. So go ahead, pause the video, try to work through this, and then when you're finished with the problem, unpause it and you can look at my work. Okay, your final answer should have ended up with 8 over x, like you can see here at the end of my problem. Now I'll just quickly walk through this with you first. First thing we had to do is factor all the denominators. X plus 1 doesn't factor. X squared minus x, you can factor an x out of both of them to get x times x minus 1, and the third one is just an x. Therefore, our least common denominator was x times x minus 1. The second step is I created the equivalent expressions. So you can see I multiplied each of the fractions by whichever factor they were missing. You can see that the second one I just multiplied by 1 over 1. Since it already had the least common denominator, we didn't have to multiply by anything additional. You would not have to do this step. I just wrote it out to keep things consistent. Multiplied each of our fractions together. And then in this step down here, I added or subtracted all my numerators. And then I came up here and combined like terms, and I noticed that these each have a factor of of 8. They each have a factor of 8, so I factored that 8 out, and see that they both have an x minus 1, which canceled, to leave me with 8 over x. If you have any questions about anything in this video, please either find the time in the video and email me, or you can take a screenshot of it and email me, but ask your questions. Good luck on the assignments, and make sure you do all your handwritten work and upload that in the Dropbox, and I'll show you how to do that in another day or so. Good luck. Bye.